This video tutorial describes how to use GCimage software to generate quantitative reports for comprehensive two-dimensional gas chromatography. The first step is to create a new project. To create a new project, select File, New Project. In the browser, indicate the folder and the name for the project file, then save the project. As seen in the browser, GCimage creates a folder for the new project. In the new project folder are the GCProject file and subfolders for vials, runs, processing files, images, and reports. The second step is to add composition tables describing the mixtures in the calibration and sample vials. This example illustrates the ASTM D5580 method, which uses internal standard calibration. There are 5 calibration vials and 1 sample vial. The composition of each vial is described in a simple comma-separated value, or CSV file. The CSV file for the first calibration vial lists the BTEX chemicals of interest and 2-hexanone, the internal standard. In this example, the CSV files are placed in the new project's vials directory, where they can be read automatically. The third step is to name the vials. In this example, the vials have the same names as the CSV composition files, so the compositions can be read automatically. The project tree, shown on the left, pictures the project components. At the lowest level are the vials, from which all analyses proceed. To add vials to the project, select the Vials branch of the tree. Then click Add Vials. In the Add Vials dialog, indicate the name prefix, the starting enumerator, and the number of vials for that name. Then click OK. If there are composition files with the same name, they can be imported automatically as shown here. Clicking on a vial leaf shows the vial information page and buttons for manual operations on the composition table. The sample vial is added with the same sequence of steps. The fourth step is to create processing files. This tutorial shows how to import files that already have been developed. To copy files to the Processing Files folder, first select the Processing folder on the project tree. Then click the Import Files button. In the browser, indicate the folder and the files to be imported. In this case, the processing files developed for an older program are reused in the new project. Then, import the files. The processing files can be shown by expanding the Processing Files branch of the project tree. The fifth step is to process runs. GCProject supports auto-processing, which processes runs as soon as they are available in the Runs folder. To start auto-processing, select Actions, Auto-Process. In the Auto-Process dialog, indicate any acquisition parameters which may not be found in the file. Also, indicate the processing configuration file and operations to be performed. In this case, the processing steps are baseline correction, blob detection, and template matching with the indicated template. Clicking the Start button begins auto-processing. Then, any new runs in the Runs folder will be processed automatically. The chromatographic system can be set to acquire data to the Runs folder, or the files can be copied manually. In this example, the first chromatogram is a run from the first calibration vial. During auto-processing, the new run is recognized and the indicated processing is performed, with each step shown on a log that is both presented on the screen as processing proceeds and saved in a report file. In a matter of seconds, the data is imported, the configuration is set, the baseline is corrected, blobs are detected, the template is loaded, matched, and applied, and the resulting image is saved. After all runs have been acquired and processed, stop auto-processing and close the dialog. The report generated by auto-processing is available in the Reports branch of the project tree. The next step in this example is to indicate the vial from which each chromatographic run was made. This step can be done before or after runs are processed. Each run is listed in the Runs branch of the project tree. Runs without a vial association are listed with a red dot. To associate runs with a vial, select the Runs folder on the project tree. From the Runs information pane, select one or more runs and their vial. Then click Associate. Associated runs are listed with a green dot in the project tree. The overview in the project tree shows the logical organization of the project. Under each vial are the chromatographic runs taken from it. Under each run are the analyzed images of that run. After the calibration runs are processed, they can be grouped as a batch and used to create a calibration table. To create a batch, select the Batches node on the project tree. In the Batch information pane, click Add Batch. Then select the processed images to be grouped in the batch, set the batch name, and click OK. The Batches branch of the project tree lists each batch. Under each batch is a list of all the processed images in the batch. To create a calibration table from the batch, select Actions Calibration Table. On the Export Calibration Table pane, select the batch from the list of available batches and click OK. Then provide the file name and format. Information for calibration is extracted from the processed images in the batch and written into the table. Each processed image in the batch is examined, so the time for building the calibration table depends on the size of the batch. For typical projects, this process takes less than a minute. The calibration table is added to the Processing Files folder, where it can be used to quantify subsequent runs. The sample runs are processed and associated with vials similarly to the calibration runs, except that they are quantified using the calibration table. In the Auto Process dialog, set the vial association to the sample vial and set calibration with the calibration table. Also, a simple report can be generated automatically for each image. The final step is to generate quantitative reports. The simple reports, which were generated automatically for each image, can be accessed from the Reports folder of the project tree. Simple reports can be configured with sections for Image Attributes, Image Viewer, Blob Table, and Blob Set Table, with quantitative results. GCProject also supports more formal reports from the Reports menu. This example shows an internal standard report. In the Internal Standard Report dialog, select the calibration batch and the images for reporting. Then select the desired subreports and click OK. Provide the file name and the format. The Internal Standard Report can be formatted in XML with user-accessible style sheet for viewing in a web browser or in CSV or HTML format. The Internal Standard Report is placed in the Reports folder, where it is accessible on the project tree. The Internal Standard Report has details of the calibration for each chemical, including color-coded graphs. The report also provides a least squares fit for each calibration function. There are quantitative results for each image and a consensus report with means and standard deviations. As shown in this video, GCimage produces quantitative reports from chromatographic datasets in just a few minutes. To learn more about GCimage software, visit www.gcimage.com or send email to info@gcimage.com. To license GCimage software, visit www.zoex.com or send email to info@zoex.com.